So in this section, we're looking at some applications of quadratic equations. So we're going to get problems that have a formula in most cases that we want to start with the formula, plug in what we know, and solve for what we don't. So here's an area problem. We got an architect that's designing an entryway in a restaurant, and she wants to put a triangular window above the doorway. Due to energy restrictions, the window can only have an area of 120 square feet, and the architect wants the base to be 4 more than twice the height. We want to find the base and the height of the window. Well, first thing we need to know and remember about a triangle, any triangle, triangles have base and height. Okay, so we've got the height is that perpendicular distance from the top to the base, from a vertex to a base, and the base is a particular side. Okay, now the area of a triangle, is 1/2 base times height. For a rectangle, it's just length times width. Now, that'll be useful also. Okay, so for a rectangle, remember, area is just length times width. That will come in handy when you're doing these. But this one's a triangle. All right. So we know this. We know that the base is going to be 4 more than twice the height. Okay. So we have the base is 4 more than twice the height. Well, twice the height is 2h plus 4. Well, now we know that this can be substituted into here, and we also know that we need 120 square feet. So we want to maximize, we want it as large as possible. Okay, so we want 120 is going to be our area, and we got 1/2, and in place of b, we're going to put this expression 2h plus 4, and we're just going to copy the h. So we substituted for the a that we knew, the area, and the base that we know. And now we got an equation that only has one variable, and that's good. Now we can solve this equation. So we got to distribute. Let's clean this right side up. If we distribute the 1/2, we get h plus 2. Now careful, we got to keep the parentheses still because we got h here. Now if we distribute this h, we got h squared plus 2h. Now we have a quadratic equation. We know how to solve these. We got different methods. Let's hope we can factor it. If not, we'll have to use a quadratic formula or something like that. So to factor, we want to set it equal to 0. H squared plus 2h subtract. Well, subtract 120 from both sides. So we subtract the 120 over. Now we want to try to factor this. And we think of all the numbers that multiply to 120. And we need ones that add to 2. And I think our numbers are 12 and 10. And because they need to add to positive 2, we're going to have positive 12 and negative 10. So we have two answers. We ask ourselves, what makes this 0? Negative 12 does. What makes this 0? Positive 10 does. Okay. Well, it doesn't make any sense to have a negative 12 height. So our final answer is the height is 10 feet. And the base is, plug in 10, 2 times 10 plus 4, 24 feet. And there's our answer. All right. There you have it. Well, let's look at some different triangles here. Another formula that comes up is called the Pythagorean Theorem. When we have right triangles, now this is only for right triangles, there's an important theorem called the Pythagorean Theorem that says this. It says the sum of the area of the squares on the legs is equal to the area of the square on the hypotenuse. And you say, what? Well, when we have a right triangle, we have three sides. This right angle here is made up by two legs. These are called the legs. So the two legs make the right angle. This is the right angle, it's 90 degrees. This other side is called the hypotenuse. So the longest side is called the hypotenuse. And you probably have, hopefully, you've run into this in other math classes, so hopefully this is reviewed. But the key is this. The square of the legs, the two squares on the legs, add up to the square on the hypotenuse. So if A and B are the two legs, then the area here is A squared and B squared. And those have to add up to C squared. So that's the Pythagorean theorem. C is always, always, always the hypotenuse. That's important. The longest side. So we're going to run into situations where we just want to find the missing side. And we know A and we know C. Well, let's plug it in. We've got A squared plus B squared equals C squared. So 10 is A. We don't know B. And we've got C squared is 26 squared. So we've got 100 plus B squared equals 676. And if we subtract 100 from both sides, we get 576. And using the square root method, we can square root both sides. And we find out that B is 24. The square root of 576 is exactly 24. Now, by the way, when we're solving our quadratic equations, we have plus or minus 24. But does it make any sense to say that the side length is negative? No, that doesn't make any sense. So we just want the positive. Well, now we're going to get some little twists on this here. So here's a situation. You'll have one like this in your assignment. The shortest leg of a right triangle is 2 centimeters shorter than the other leg. Oh, so we have two legs, A and B. So we've got A. Let's say that A is the shortest leg, all right? And that's 2 centimeters shorter than the other leg, okay? So one leg is B, okay? Let's say the other leg here is B. That means that A is 2 centimeters shorter than B, okay? So B is the long side, and you got the short leg, and this is going to be B minus 2. And then we got the hypotenuse. Now we know the hypotenuse is 10. So drawing will help here. So we have something like this. What are the lengths of the two legs of the triangle? Well, let's work this out. According to our Pythagorean theorem, A squared plus B squared equals C squared. Well, we know the hypotenuse is 10, and we know A is going to be B minus 2. So we got a quadratic equation going on here. So we know that 10 squared is 100. Got our B squared. Now be careful here. Don't go squaring these two. If you just square this and square this, you won't get the right answer. So remember, we got to either write this out, B minus 2 times B minus 2, or remember our rule that says A minus B squared is going to be A squared minus 2AB minus B squared. So the first thing squared minus, that's actually a plus, minus 2AB plus B squared, the last thing squared. So let's try that out. So this is going to be square the first thing b squared. Square the second thing. That's going to be plus 4. And then multiply and double. If you multiply these, you get negative 2b. Double that, you get negative 4b. So there's our quadratic equation. Let's go ahead and clean this up. Let's add the b squareds together. We got minus 4b. Let's go ahead and minus 100 and minus 100. So that's negative 96. Now if we divide everything by 2, because we notice everything's divisible by 2. So if we divide everything by 2, then we end up with b squared minus 2b minus 48 equals 0. And we need two numbers that multiply to 48 and add to 2. I think we're talking 6 and 8. 6 and 8. And they actually subtract to make 2, or they're negatives. So we're going to have 6 and 8. We want them to add to negative 2, so there's negative 8 plus 6. So we factored it, and now to solve it, we need to ask ourselves, what makes this 0? Well, that's negative 6. What makes this 0? That's 8. Does it make any sense to have a negative side length? No, it doesn't. All right, so that's gone. So B is 8. We want the length of the legs, both legs. So the legs are 8 and 6, because we know that A is B minus 2. So we've got to plug that in to find the other side. And so our legs are lengths of 6 and 8. Now there are units. So we should put our units in here. The units are centimeters. So let's go back and put that in there. Watch out for units in your application problems. All right, there you go. So we can also run into another Pythagorean Theorem situation here. We've got a right triangle. We've got a tower that's being built. We've got a guy wire holding it up here. And that's attached 70 feet from the base. All right, so the wire is attached 70 feet from the base. How long does that wire need to be? Well, we got a right triangle. And so we know the legs squared equals, if we add a squared plus b squared equals c squared. So the legs squared added together equal the hypotenuse squared. So we've got 2,500, 4,900, and c squared. And this is going to be 7,400. And if we square root, in this application problem, we're going to want to get a decimal. And so that is about 86.02 feet. All right. Well, what if we knew we had 100 feet of wire and that we wanted to use? How far from the base should we anchor it so that we can attach the 100-foot guy wire? And we want it to be at 90 degrees. We've got our tower. We want this to be 90 degrees. We'll assume that part. We know we've got 100 feet. We know the tower is still 50 feet. And what we don't know is we don't know this distance here. Maybe call it x. Well, so a drawing would be helpful here. So that's what's going on. We know that much. So we just plug in the Pythagorean theorem. 50 squared plus x squared equals 100 squared. The hypotenuse always goes in the C spot. Hypotenuse is always by itself. Okay, don't go putting the x on the right side. So this is 2,500. And this is 100, also known as 10,000. And if we subtract 2,500 from both sides, we get 7,500. And if we square root it, then we're going to get, this gives us about 86.6 feet. And that's the horizontal distance, not the hypotenuse. That's how the Pythagorean theorem works. So let's look at some other situations here that involve quadratic equations. So a lot of physics situations, especially things that deal with falling objects or objects flying through the air, a lot of them involve some quadratic equations. So here's a formula for a free-falling object. S of t equals 16t squared. So this is the S is the distance that it's fallen. So if you drop a penny from the top of the roof of an Empire State Building that is 1,250 feet high, how long will it take to reach the ground? So if S of t is the height, or more specifically the distance it's fallen, we want it to fall 1,250 feet. Here's our equation, 16t squared. There you have it. So we take our equation that's given to us. We fill in what we know. We know this is the distance we want to travel till it hits the ground. And we can solve that. So let's find out. I'm kind of interested. Let's find out. If we divide by 16, we get, I'm just going to leave it as 1250 divided by 16. And then that equals t squared. And so we'll just square root that to get our final answer. And we get t is approximately 8.84 seconds. All right. So you have 8 seconds to say, watch out, even though no one will ever hear you down below. All right, projectiles, these also give us quadratic equations. So when something's flying through the air, it's a projectile. It's an object that is propelled into the air without any means of self-propulsion. That's a projectile. So if something's thrown through the air, like a ball or something like that, then we get this equation, S of t. This is the height. Okay, so the height is S of t. Let's make a note of that. That's the height of it. S sub 0, or sometimes we could say S naught. It's a British kind of thing. Plus V naught, the initial velocity, times time, minus 1/2 times gravity times time squared. Okay, well, there's the physics background. Height. All right. So this is just vertical, up and down. It's not the horizontal position. All right. Well, let's try some problems out that involve this formula. So a bullet is a projectile. Okay, a bullet is shot in the air off a 128-foot building. It's got an initial velocity of 320 feet per second. And so the function of its height looks like this. All right. So S of t equals 128 plus 320t minus 4.9 t squared. So this would be if it's like shot straight up in the air, all right? So what will its height be after 1 second? Well, that's S of 1. This is function notation, which means we want to put 1 in for t, so t equals 1. So that's 128 plus 320 times 1 minus 4.9 times 1 squared. So we just plug it in and do the calculations. Well, 1's kind of nice because it's just 1. 1 squared is 1. And 320 times 1 is 1, 320. If it was anything else, you'd probably want to use your calculator. 320 minus 4.9, because 1 squared is just 1. And that's going to be 448. 8 minus 4.9, so that would be 443.1. And that is the height. All right. So that is feet. Now the question is, how long will it take before it hits the ground? Well, that means we want the height to be 0. the height off the ground. So we want S of t to be 0 for our height. So when will 0 equal 128 plus 320t minus 4.9t squared? Well, this is going to be a good one probably to do the quadratic formula with. So this is in standard form, or we can rearrange it. We should. Negative 4.9t squared plus 320t plus 128. Now, what does the quadratic formula say? It says t equals, t not x in this case, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And we'll just go to our calculator and type this in carefully. Now, which one should we use, the plus or the minus? Well, you're going to have to kind of try both. So here I've plugged them both into Desmos separately. You got to be real careful with these negatives and all that. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Watch out for those negatives and things like that. So here's what the plus version, here's the minus version. The plus version gives us a negative 0.39, and the negative version gives us 65.7. All right, again, what are we looking for? We're talking about the height of the bullet. So the negative doesn't make sense. Or I'm sorry, we're finding the time, how long it will take to hit the ground. So the time is about 65.7 seconds. And so that would be the minus version, actually. Okay, that has to do with the fact that there's negatives in there. All right, so that's the idea. So when it hits the ground, that means the height is 0. We can solve it up from there. And let the quadratic formula do the work. Well, we'll run into other quadratic equations and applications. Here's one. We've got the amount of precipitation in Sonoma, California. Is approximated by this formula, p of x equals 0.2x squared minus 2.8x plus 9.8. So p of x is the inches and x is the number of the month. So 1 is January, 2 is February, so on and so forth. So what's the amount of precipitation in March using this model? So let's find out. So January, February, March, that's 3. So x is 3. So we're just looking for p of 3. So x is the number, the month number. March is 3. So 0.2 times 3 squared minus 2.8 times 3 plus 9.8. Let your calculator do the work here. And this gives us a prediction of 3.2 inches of rain. All right, that's interesting. Well, when will there be no precipitation? Well, p of x is the precipitation, so when will that be 0? That means we want p to be 0. So 0 is 0.2x squared minus 2.8x plus 9.8. All right, so we have x equals... All right, these are quadratic formula here. So let's work that out. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, before I go to my calculator, I might clean up a couple little things here because the more I punch into my calculator, the more chances I'll make some mistakes. Like I actually did on the last one, I put a negative in the wrong spot. So negative negative makes positive. it's worth the time to go ahead and do this. This negative doesn't matter, so it's just 2.8 squared, because when you square it, the negative goes away. All right, I'm not going to try to do too much in my head. You could. I mean, we could. 4 times 0.2 is 0.8. I don't want to go any further than that. Okay, you don't have to do that. 2 times 0.2, well, that's 0.4. Okay, that's easier to go to our calculator now. So I'm going to go punch this in. Now, the positive one is going to be the positive. If I do a negative, that's going to probably give me a wrong answer. But we'll try them both. Now, one more thing. Be careful. If you're doing this in a graphing calculator, put this whole thing in parentheses and then divide it by 0.4. Now, surprisingly enough, they both actually come out with 7. So when you plug in the positive and the negative, we get 7. 7 is July. So this, according to this, the month with no rain will be July for Sonoma, California. Sounds reasonable. So that's the idea. So all of these here, we're getting a formula that is a quadratic equation in nature. Look, it makes you understand the equation and what the variables mean. That comes from the problem. Makes you understand what you know and what you're looking for. Here, March gave us the x value. No precipitation meant something 0. No height meant 0 height. Plug that into the equation and solve in whatever way you need to. Good job. I hope that helps. And go solve some problems.